YouTube team at Google, who's going to tell us about his project Vitess.
Hi. So some disclaimers. This is the first time I'm talking about this, so it's not rehearsed. So I may fumble around, so excuse me if I do. So as Andrew said, my name is Sugu. I work for the YouTube team, and I'm not part of the Go team, and but I actually like them a lot. We started Vitess around 2010. That was about 3 years ago. That was the time when Go was just announced, and people were experimenting. And our main decision to use Go, when you read up about the language, you don't really know how far you can go with it. But we made our decision based on the Go team and where they are coming from, how they are thinking, and we kind of liked the way they were thinking. They were minimalist. They were not trying to just keep adding bells and whistles. They were actually trying to remove stuff that is possibly unnecessary, simplify things, and making the right trade-offs. So we felt like they were heading in the right direction in terms of language design and what they wanted. And even their libraries, when we looked at them, looked like it had a lot of maturity in how they thought about it. So we took the risk to decide to do this in Go, and we don't regret it. What I would like the outcome of the talk to be is basically say that at this point, if you're on the fence, thinking about using Go, you don't have to worry about it. You can jump in. For example, just to say, YouTube completely depends on this server. If our Go servers go down, you will not be able to see a single YouTube page. So that's how much we depend on Go. Actually, before I jump into the details, I have a large number of slides. I wanted to get a quick idea about whether you want to hear more about Vitess or you want to hear more about the Go experience that we had, some of the Go stuff. How about Vitess? How many of you want to hear about Vitess? There's like 5. How about Go? 5 more. Okay. So I will probably try to do 50-50, and I'll try to finish about 15 minutes early for questions. So what is Vitess? It's basically a scalable and efficient storage solution for the web. So in other words, YouTube is the ideal customer for Vitess because that's the reason why we built it. But if you are actually writing a web application and you want a scalable solution, and you're starting off with MySQL, and then eventually when MySQL runs out, you want to know how to scale, you can think about using Vitess to keep scaling while you continue to use MySQL. So what does Vitess give you is, on one side, it gives you a set of tools to manage your MySQL instances. And on the other side, it also gives you a set of servers that actually run on top of MySQL that actually optimize MySQL performance, that actually make it go faster, if you can believe it. I will give you share some numbers about how we managed to do that. In terms of, I don't know how many of you are familiar with NoSQL and MySQL. On one side, there's the MySQL, which is pretty good to get started. It's relational, which means that it's functionally very rich. It can do lots of tricks. But it's also, because of the fact that it's a relational database at heart, eventually it runs out of steam when you start to scale. So on one side, that is a problem that MySQL engines have. On the other side, we have NoSQL databases that don't have trouble scaling, but then when your application becomes more complex, you start to run into limitations about what a NoSQL engine can do, especially in the areas of indexes. They don't support secondary indexes. They don't support joins. I think people are it's mainly because NoSQL engines are still relatively new. Some people are trying to add these things, but if you want transactions and all that, that's very difficult code to get right, which actually MySQL already has managed to get right. So what Vitess tries to do is actually kind of go in the middle. It basically takes MySQL and makes trade-offs on the relational aspects of it and kind of push it closer towards NoSQL, but not all the way. So which means that you can scale you can keep on sharding, you can keep on growing, but you also don't lose transactions, you don't lose joins and indexes. So that's more or less what Vitess is. Basically, again, our philosophy is make the right trade-offs so that you don't lose everything. So this is the kind of what I'm going to go through is more or less the story that YouTube went through when we started to scale. When YouTube was founded, it was just one single database. But as soon as you do here, you'll run into one of those problems sooner or later as you start to scale. Your data size can go too big, it may not fit in one database. Your QPS could be too high, the database may not be able to give you the QPS that you want. Uptime becomes a problem because sometimes you have to do maintenance on it. You go alter a table, then you have to bring down the database, you have to take backup. That's also another problem. Crash recovery, sometimes it crashes and then you lost all your data. And also, eventually, sometimes the number of connections you make to the database can also become a problem. The reason why I say let's ignore this for now is because usually number of connections is a problem that you face when you've gone far ahead with your scaling solutions. So the first thing that people do is add replicas. There's a master database and you add replication. That immediately gives you a big breath of fresh air. A whole bunch of problems are solved. There's no backup issues because you can take backup from a replica. You can distribute your reads across multiple replicas, so there's no more issues with reads. Your QPS goes up, and there's, like I mentioned, there's no issue with if there is a crash, you can immediately fail over to a new replica and continue serving. So this is actually the biggest bang for the buck you can get from trying to scale MySQL. But this is not enough. Eventually, the next problem that you'll end up solving is that sometimes you want to use replicas for full table scans where you're doing like MapReduce kind of stuff, where you're mining data, and then you want to also at the same time serve OLTP traffic, which means that the web servers are hitting the database. The query patterns are very different, and for cache to be efficient, you usually split the data into categories. You say, I'll reserve one database for just MapReduce kind of jobs where you can do your full table scans, and then I'll reserve another database for web traffic, which will basically do random access reads into give me the info about this user and that kind of stuff. So that improves utilization. Actually, that will buy you some time in terms of scalability because you basically used different caching to make sure that you can keep working with the hardware that you have. But eventually, this will also run out of steam because you still out of steam because eventually write QPS is going to become a problem. There is only one master, and you can't keep on increasing the write traffic to that master. At some point of time, the disk is going to say, I can't write any faster than I'm writing now, is when the next thing that happens where we do sharding, where we say, okay, we split the master into ranges. All of you are familiar with sharding? I assume, yeah. So you split the master into ranges, which means that you divide your write traffic. So write QPS is gone as a problem. Data size is not a problem anymore because sharding solves that problem also. But then you've introduced some new problems. You introduced the problem of tracking categories. You've introduced the problem of write uptime because, hold on, write uptime, yes, write uptime because you cannot, if a data center goes down, then there's no place to fail over to. There are still complex client issues. Now that you're sharded, your client becomes a lot more complex because they have to figure out where to send the traffic. The resharding itself is a problem with MySQL because MySQL allows you only to replicate an entire database to another. It doesn't allow you to split a database when it replicates. And the number of databases is also growing, so that also becomes a growing problem because you don't know when something goes down, you don't know which replica it was, so you need to start tracking all these things. And like I mentioned, disaster recovery is another problem that you'll eventually. So if you've gone this big, you probably care enough that if an entire data center goes down, you want to be able to recover somewhere else and continue serving traffic. So far, so good. No more questions? No questions so far? Okay. And here is what happens when you add new data centers. Now you have a farm of databases. Not in this particular order per se, but this is basically where we are now. We have the only things that have happened on top of this is we now multiple of these databases, and we also have what we call lookup databases, because some of these tables require secondary indexes, and those indexes span across multiple shards, and we need a separate database to maintain those indexes. So if you add all that, we have a large number of servers, and we could not just have some people have a file as a list of a JSON file that described these things. We needed a lot more than just maintaining this list. So this is where we thought of a log server. Zookeeper is the common open source log server. How many of you are not familiar with Zookeeper? Okay, so Zookeeper is what we call as a log server. It's basically I would say a single point of failure, but the way they solve that single point of failure problem is they have 3 or 4 multiple servers that keep talking to each other and exchanging data very quickly to make sure that if one server goes down, the other one still has the data. There is something called the Paxos algorithm that they use, which is very latency sensitive, which means that typically a log server is very good for atomically updating data, but you have to limit how much you use it, because if you write too much data to it, it kind of falls apart. But you need it because when you take a server down, when you say, oh, I'm changing the master from this database to that database, that change has to be atomically updated somewhere so that everybody else receives that update atomically. So they are very useful, but if you should know how to use them. So the log server that we use for the open source is Zookeeper, and internally in Google we use Chubby. How many of you have heard of Chubby? Okay, so Chubby and Zookeeper are functionally equivalent. So internally we use Chubby. What it keeps track of is key spaces. Key space is basically what is a logical database. Like a database that is sharded into 10-way is one key space. Like we have a user key space, we have a claim key space. So that's what a key space. It keeps track of the shard graph. It says each database is now split 16 ways or 32 ways. It tells you the ranges that we split them by. It keeps track of the list of master databases, but there's only one master per, and then a whole bunch of replicas, one master per shard. And it also keeps a list of data centers. You say, right now we are running in 5 data centers, and these are the lists, or 7 data centers. And each data center also has its own log server, which keeps track of how many replicas are running there, what are the categories, and where, if you want to read data from a database, where should you go? That's the serving graph. The reason why we split it is for fault tolerance, which means that if the global server goes down, we continue to serve traffic because there is a local log server available. If the local log server goes down, there's still other data centers that can take traffic. All right, going well so far. So there are to work with these log servers, we wrote some tools. There's one big tool which we call VTCTL, which stands for VT control. Using this tool, you do all your operations for Vitess. You can say VTCTL, do a reshard. You can do VTCTL, do a reparent. So you'd say VTCTL, and there's like about 20, 25 commands that you can issue. Pretty much everything that you need to do to maintain that big farm of databases that I showed, you can do using VTCTL. The way it does it is it registers an action inside the log server saying that I'm going to do this work, and then goes and performs the work, and then comes back and updates the log server. Okay, the work is done, and then all other services are listening on that log server, and then they pick up from there and react to it accordingly, depending on what the change was. So there is also a web server that kind of reads from that log server and tells you where things are. So if you go to the web server, you'll say, okay, these are your masters, these are the databases that you have, these are the replicas, and you can click on each replica and look at what is going on there. So that's just convenience. And then, any questions? Yeah. And then we have servers. These servers, we wrote them for both simplification, improving performance, as well as management. So VT Tablet actually is a proxy server. Every MySQL instance that we run, there's a VT Tablet in front of it. Actually, none of our applications directly talk to MySQL anymore. They all go through VT Tablet. It gives you an RPC API, and you send it queries, and then it returns results for those queries. So pretty much, as far as the application is concerned, you are talking to a database engine. You don't even know that it's MySQL, even though underneath it is MySQL. The first thing that VT Tablet did was to pool connections. For example, when we at some point of time, this was in 2011, we ran out of memory because our connections were so high. I think we were at about 4,000 connections, and MySQL just couldn't handle more than that. And when a server went down, a new server came up, and all web servers connected to it and made 4,000 connections, MySQL would immediately die again. So it's like the thundering herd loop of death, where you are never able to recover. So the first thing that VT Tablet did was accept as many connections as you like, and then pool it into a limited number of connections. Actually, if you MySQL, you can max out MySQL with just 8 connections. If you have 8 connections and you pound it with queries, MySQL will be maxed out. You do not need more connections than that. So actually, in reality, we run about 24 connections because some people are still not trusting that you can max out MySQL with 8 connections. So we run it at 24, but you don't really need 24 connections. But on the front end, right now, VT Tablet receives like up to 40,000 connections so far. That's the highest number of connections that we have. In terms of memory cost of that, each MySQL connection costs around 2 megabytes. That's amount how much it requests, and multiply that by 40,000 and look at how much memory we saved. And that's how VT Tablet makes MySQL go faster, because if you send all those connections to MySQL, it would barely perform. Apart from that, what VT Tablet does is it also syncs in with the log server, and if some work that needs to be done, like for example, if you want to take a backup, you can go to VTCTL and take a backup of this database, and using the following VT Tablet, then log server, VTCTL stores a command on the log server, assigns a command to VT Tablet to execute, and VT Tablet says, oh, I need to take a backup. Let me stop my query service. Let me stop my replication and take a backup. And once the backup is done, I'll come back and then restart replication and go back into serving mode. So those are things, a large number of workflows basically that are common when you are running a big farm of databases are all automated through Vitess. The VT Gates query server solves the complex client problem. It's actually one level above VT Tablet. What it does is acts as a single server and hides the fact that there are multiple shards in the background. So when you want to, so right now we are at a phase where we are transitioning from VT tablet to VT gate. We should be done with the VT gate migration in about a month or two. And that should also, it's available right now, but it's in the process of, it's not functionally fully complete. But once that is complete, you will stop connecting to VT tablet, you will connect to VT gate. Its API is very similar to VT tablet, except that instead of talking to a single MySQL server, you are talking to the entire farm. So at that point, you send it a query, and then VT gate will look at your query and say, oh, okay, I need to send this to the following two shards, and then get the response. It also takes care of if there is if the master changes from one database to another, VT gate notices that, saying that, oh, you wanted to do a write, but the master just went down. Here's the new master, I'll send the query here instead. So all the complexities of the big farm behind behind the VT gate is hidden by it, and then the application remains simple. So that should help you with as you. In our case, we actually have a complex client, and now we are simplifying it. But once Vitess is released, if you have a simple client, it will remain simple, because as you scale, you just continue using one server, which is VT gate, and it will keep hiding the fact that you are sharding underneath. Here's a view of how things stand. You can see that there's MySQL databases in the bottom, and there's a VT tablet, one each for each of those, and there's a VT gate that sits in front, and the application just connects to VT gate. This means that VT gate has actually a SQL parser. VT tablet also has a SQL parser, which I'll talk more about as we go. So they understand queries, they know what to do with them. And VT tablet and VT gate talk to the metadata, which is the log server, Zookeeper in our case. And on the other end, VTCTL, using VTCTL, you issue commands. Those commands get updated in the metadata, and these guys pick up the change or perform actions if something needs to be done. This is the view, and VTCTLD is something that is there for you to browse what's going on in there. We have some command line tools also called ZK, where you have file system like an API. You can do ZK/VT/master, show me this, and then it'll give you nice JSON files that you can look at to see that represents the metadata. Any questions on this so far? So far, so good. All right, I'm going to speed up because I want to also spend time talking about Go. So this is basically what Vitess does for you. Is it takes you from point A to point B, hopefully with not you having to rewrite your app a lot based on the fact that you're changing things underneath. Why servers? Mainly because the problem with MySQL is that it's a relational database at heart, and it is meant to stick to the contract of a relational database, which means that there are some very tough decisions, compromises that it has to make. For example, transactional safety. You have to have transactional safety, otherwise you're not a relational database. You have to have isolation, otherwise you're not a relational database. So what we can do is we can say, well, how much of transaction safety do you need? We can start negotiating. So we did those negotiations within ourselves and said, okay, these are some of the things we can trade off for which we can get some scaling. Like I mentioned, cost of connections is a big concern. And MySQL has to do it because they need to isolate one user from another and what they do between each other. And therefore, MySQL cannot do it, but we can. We can say, well, we'll accept 40,000 connections, and we'll have a pool of 24 connections connected as just one user, and we'll just rotate them as we need. So then we can afford to do that. So we solve the connection problem. MySQL doesn't know how to judge your queries. Any query you give, it has to give you an answer, and it will work hard and at the cost of other queries. So that actually is a problem in a web app, because there is one query that is expensive that can bring the entire database down, and that will cause an outage on your web server. So what VT Tablet does is it looks at your query and says, is this query safe to send to MySQL? How come you don't have a limit on your clause? So you don't have a limit on your clause, I'm going to slap a limit there and make sure that you don't return more than n rows, because you are serving a web app, you shouldn't be asking for a full table scan, for example. So when it sees queries like that, it puts limits and protects the database. And like if it sees that a query is running for too long because maybe it's scanning some index, it'll go kill it. Say, oh, this query is running for too long, I'm not going to allow it to run. So while it makes these decisions, what it helps with is it helps the website running, because other well-behaved queries continue getting served. The other problem it solves is the MySQL buffer cache is designed for table scans, which means that when you read one row, it will not read just that row, it will read the entire block of memory, block that the row is stored in. And those are 16K blocks, and if your rows are only like 10 bytes each, for every row that you're reading 16K blocks of rows. And that is actually good if you're doing full table scans, you're doing MapReduce kind of work, but it's not very good for web traffic, because web traffic is say, show me information about this user, show me information about this video. So what VT Tablet does is have an alternate cache, which we call the row cache, which caches only rows, and it actually, I'll talk about a little bit more about that later. And that row cache increases MySQL serving capacity by manyfold, something like 8x. Like a typical MySQL server would be able to do about 10,000 QPS. If you added a buffer cache for the right kind of web traffic, you can probably multiply that up by 8 times. Like we haven't really maxed it out yet, but I've seen like typically QPS in the range of like 80,000 from just one box, and we are barely using like half the CPU that the box has. So there is a lot you can get out of it. Typically people use Memcache, but the problem with Memcache, like applications do their own Memcache solutions, but the problem with that is that the Memcache becomes stale, because how do you keep it up to date? Whereas VT Tablet keeps the row cache up to date, which means that the data that you get is as up to date as the database that you are getting it from. So MySQL doesn't blacklist queries. For example, if you see that there is a query that's causing a lot of trouble, you can immediately go to VT Tablet and say, okay, don't allow this query anymore, and then it'll start returning errors on those queries so that your site can keep running. And also when eventually when MySQL starts to run out of steam, it doesn't tell you much about why. It's very difficult to find out why MySQL is suffering. There are some tools which you can use to run, but this is where actually now, this was actually a very unimportant part of VT Tablet, but now it's actually one of its greatest strengths. It tells you everything that's going on, and it's very useful. It tells you in this query category, this is the query category that's actually causing you problems. This is the table that's causing you problems. So it can give you stat about table level. You can actually, if you have absolutely no clue what's going on, you can say, okay, give me a dump of all the queries, every query that executes, and every stat about that query. How long did you spend waiting for MySQL? How many rows did you return? How much memory did you use? So it tells you everything. And then you can, it comes as a file that's awkable, and then you can run your whatever tools that you like to analyze and say, okay, this is the query that's causing problems. So that's actually one of the things that we have used a lot of recently. Whenever there's an outage, okay, let's go look at the table stats, let's look at the query stats, and let's see what's going on there. And on the other side, because of the fact that we have sharded, we need some abstraction. We need the application to remain simple, and that is the other part that we need servers for. All right. I'm going to now skip through because I want to spend more time talking about Go. But I've already covered the important things about VT Tablet. Connection pooling I've talked about. Oh, results reuse is another cool thing. like if let's say your front page has some information and it's causing query spam. Like there's one query that's executed at 5,000 QPS, and it's just one query, it's always the same result. So what VT Tablet does is that every query that it is currently running on against MySQL, it knows that that query is currently executing. If any new requests come in that are the exact same query, it doesn't send it. It just waits for the result of that query to come and then returns that same result to everyone else. It's brain dead stuff, but I can't tell you how much it has saved us. Because YouTube is a site where a video suddenly becomes popular, or somebody who has 250,000 videos, they suddenly get featured on the index page, and suddenly the index page is fetching 250,000 videos for every index hit. So when these things happen, VT Tablet saves you by just saying that at any given point of time, only one of those queries will run, not 10,000 of them. So VT Tablet has an SQL parser, which means that we invested into a parser because we felt that once we can parse, we can have better control, and that's beginning to pay off. There's lots of cool tricks we can do. We can now blacklist queries by all kinds of things that you typically cannot. And I've talked about the row cache. The other thing that we can use the row cache for, that VT Tablet can use the row cache for, is not just for primary key lookups. Like if there is a query that comes that requires an index scan, what VT Tablet does is it looks at the query. Oh, looks like this is going to be an index scan. So let me just scan the index, get the list of primary keys, and then see how much of it is in the row cache already. And then I get the stuff from the row cache. The only stuff that I go to MySQL for is stuff that is not in the row cache yet. So it also makes MySQL go faster with those techniques. There are also fail safes that I talked to about. There's transaction management. I limit the row counts. I limit the number of transactions. MySQL will die if you open too many transactions. If you have over 1,000 transactions open, it will just die with rollback segment errors. I have timeouts. We have blacklisting. So all these things basically have helped YouTube stay up. And also we have DML annotations, which means that every write query that comes in, we know which row it changes, that we can later use for other things. That I'm going to skip because I'm beginning to run out of time. So here's what a block diagram of VT Tablet. There's an RPC service on top, which actually we use Go's RPC for. There's a query parser which actually caches plans, which means that a query is parsed only once. Once it is parsed, then there is a execution plan that is built for it, and then we reuse only the execution plan. It goes through the query rules to make sure that nothing is blacklisted. It reuses results. There's a connection pool, and there is a transaction pool. The MySQL writes every statement into the bin log, and that bin log, we now have tools that parse those bin logs and do lots of cool tricks with it. One of it is to invalidate a row cache. So if you made a statement that changed a row, what we do is we continuously read that bin log. It says, oh, this row has changed, let me invalidate the row cache. So that is how we keep the row cache consistent with the database. We also use it for filtered replication. So when you say I want to shard my database into 16 or into 8, the filtered replication can read each statement and split the rows. This is something that you can't do with MySQL standard replication, but you can, when you want to do sharding, it will do the split. And we have a workflow that fully automates this, which means that you say go reshard, and this is the key space ID, this is the key on which you have to do the sharding, and VTCTL will start the workflow that will initiate this filtered replication. So basically at the end of replication, it will say replication is done, you are ready to switch traffic from the old scheme to the new scheme, and then you do the scheme, which should take a few seconds to switch, and then you're up on the new scheme with multiplied read and write capacity. And there is also the update stream, which is if you want to export your data continuously to an external server like Bigtable or any other service that you want to store into for other processing that you want to do, you can subscribe to the update stream, and that will tell you that will basically stream a list of rows that are continuously changing. So you don't have to keep on doing full table scans to get an update of what has changed. All right. Vitess is production ready. It is, unfortunately, right now only we can operate it. It's not quite ready for unsupervised use, but it will be ready very soon. We are very, very close. Probably in about 2 months. You can download it. It builds. We use it internally. It's just that we don't have enough documentation, and we are also making changes. We are changing the APIs a little bit and stuff. So you can download and play around with it, but you can probably use it for production also. I mean, we use it, except that you may need to send us a lot of emails, and we may have to answer a lot of questions if you have issues, which we'll be glad to do. We are a team of 5 people, and we are all super excited about this project. Here's some stats for you. VT Tablet serves all of YouTube's MySQL traffic. It's been in production since 2011. We have between 10 to 40,000 connections. And these connections, like when a server goes down and we bring up a new master, these 40,000 connections get made within a few seconds. So you bring down a master, bring it up a new one. Within 5 seconds, all 40,000 connections have been made. No downtime, no thundering herd. This I take no credit for it. Actually, it's all thanks to the Go runtime, because it's really, really that efficient. It's just Go code. It vastly increases MySQL's serving capacity, and if you operate at this size, the thing that you value most is the logging and statistics, and you want to know everything that's going on, because when there is trouble, you need information, and that's what VT Tablet gives you. And we are getting ready to launch Cache. We have done benchmark tests. They are looking very promising. In terms of QPS, we serve about 500,000 QPS approximately. That's what VT, well over 500,000 is what I would say. And once Cache gets enabled, there's going to be an order of magnitude increase. Probably it'll increase to 2 to 3 million QPS is what we are looking at. We only have estimates. We don't know exactly. Maybe the next time I'll talk about this, Cache would be launched. So basically, all Go code, huge QPS. You should have no fear of Go scaling. YouTube completely depends on it. There was one outage when all our databases went down due to operator error, nothing related to Go, and YouTube was down for an entire hour completely. Total blackout. It was probably in the news. It happened a month ago, I think. Yeah, every time YouTube goes down, it's the news. All right. I will jump into Go. These are final words. Google, we depend on Google MySQL. There is something called group ID that we need, which is very important for remastering. So we do depend on Google MySQL. We are looking at MariaDB compatibility, and the later versions of MySQL have group ID also. We just have to test against them. We use Zookeeper, use Go 1.2. Awesome. Go 1.2 made some of the best changes that Vitess gained from. We use Python mostly for clients, and we have other miscellaneous tools which you can get through apt-get. I'm going to skip over VTGate. So the RPC protocol that we use is actually a fork of Go's RPC. The only thing that we have added is a call context, which means that every time You get called, there is a context that tells you which IP it's coming from, because that was important. When there is a server-side problem, you will say, oh, there's this query that's bad. I don't know where the query is coming from, and then the call context tells you which IP it's coming from. We also added streaming for it, because if you're doing a full table scan, a simple synchronous RPC API is not enough. So those are two things that we added. And there are few more things that we added. We added some security, SASL authentication, SSL. We right now support BSON, GOB, and JSON. That way, Ghost RPC is very modular. You can plug in any encoding that you want, and it's very simple. These are the things that we support natively, but if you want to add thrift or protobufs, it should not be a problem. And we support Go and Python clients. All right, finally, Go experience. Vitess and Go. It was rough in the beginning, I have to be honest, because when we started using Go, it was not mature. Some of the biggest challenges we faced were, let's see, some of the biggest challenges were with respect to garbage collection, the runtime scheduler, the ePOL, the network code. But I have to say special thanks to Dimitri, who single-handedly solved all those problems for us. I don't know how many of you don't know Dimitri. You do not know Dimitri. Dimitri Yukov is a contributor to Go. It's his 20% project, or so he claims. His contributions are way more than 100% contributions from other people, is all I can say. Let's talk about, here's, I just want to give you a challenge. Here's more or less what, you now know what Vitess does. Take an estimate of how many lines of code it has. Any estimates? 20,000?
6,000?
6,000? Come on, it's an entire server. 2 million, okay, I hear something. 50,000. Okay, I last checked it was 70,000. Only we know, we've been writing this for 3 years now. If we had written it in C++, I have written a lot of C++ in the past, it wouldn't have been anything less than 200,000. No questions asked. I mean, imagine having to implement RPC protocols, having to implement encoding and decoding, having to implement memcache clients. I actually looked at the memcache client that is written in C++. That itself is 15,000 lines of code. Zookeeper client, MySQL client, BSON protocol. So it's very, very compact for what it does, is all I can say. Here's some numbers, like I wrote an LRU cache, 224 lines of code. Connection pooler, 260 lines. Memcache client, 280 lines. Not 15,000 lines. I don't know, probably, maybe I'm wrong. Maybe it's 2,000 lines. Have you seen the Memcache client code?
The Google free one?
No, there's a public API one. Anyway, it was order of magnitude bigger than what we have. Like I said, we had challenges initially when we did the benchmarks. RPC just wouldn't. It was slower than Python. Then Rob spent a week on it and then made it better. Then Seago calls became a bottleneck. And Russ came and spent a week on it and he made it better. After that we launched. After those two were solved, we said, okay, this is good enough, we are going live. So we launched VT, and then the garbage collector started becoming a problem because at one point of time, we were bottlenecked by VT code. Like VT code would be the first one to run out of steam and we couldn't increase QPS. And that was because of the garbage collector. And then Dimitri stepped in and rewrote the garbage collector, which now uses all CPUs. And that after he rewrote that thing, garbage collector just fell off our radar. We just never thought about garbage collector anymore. Then the network I/O and the runtime scheduler had to be rewritten, which again Dimitri rewrote. And now it's awesome. I can say it just Go code just screams. I'll share. Actually, in the other thing, I didn't talk about the latency. We serve this 500,000 QPS, and we are going to be serving millions of QPS now. And the average latency, client-side latency, which means that Python code that encodes a request, sends it, gets back the results, decodes it. The average latency that we have is 2 milliseconds. There is not many data stores that will give you that kind of latency. So that's how fast Go code can go. Here is a, oh my God, I'm going to skip all this. Tools. Here I would talk about debug pprof and debug vars. Those are your friends. If you're going to scale, those are two things that will tell you where you're using memory, where you're using CPU, and debug vars export a lot of variables about what you're doing, and that will tell you internals about what's going on. Let's see. I want to skip over to, oh, this I need to talk about. You have to talk about generics, right? So generics.
You don't have enough time.
I don't have enough. There are three kinds of generics. Okay, if you say Go doesn't have generics, then you haven't used the language. There is something called high-level generics. In my opinion, if you are going to write over 10,000 lines of code, that is all you need. You need high-level generics, and you achieve those using interfaces. You can use closures also. I'll show you some techniques that I've used. It requires a little bit of forethought, which means that if you're going to say that this code needs to be generic, all you need to do is think of an interface and not a struct. And we all know it's not efficient with primitive types. There is also the language-defined generics. Like, for example, if you used a map, if you used a slice, those can be of any type, and that's not a problem. It's these other low-level generics that everyone complains about, which requires code generation, which means that I have a linked list of X, right? My answer to those who want those low-level generics, use the following technique, and then don't ask about generics anymore. Here is a min.go that I wrote in 5 minutes. As you can see, it takes a generic type, returns a generic, and returns basically the min. And the way I achieve genericity is by running gofmt and say substitute generic to int, and then you have a generic int. And like this, you can have as many generic data structure implementations as you like. As a matter of fact, I tried this against container list, where I ran gofmt substitute interface to int. It generated an integer linked list, and my job is done. So this is something that you can automate. You can make it part of a makefile. It's a solution outside the language that you can use. All right. I know C++, I know Python, I've heard of Java. I think it's a language or something. So so I can't talk much about it. C++ versus Go, you almost always would choose Go unless performance is super critical, something like Memcache. You would choose C++. If you're going for a real-time system where the response time has to be guaranteed, maybe you'd choose C++. Otherwise, everything else, Go is better. Readability-wise, there's type safety. Don't tell me C++ is type safe. It's not. Compiler speed, platform independence. I mean, long. I mean, how many bytes does it take? It's platform dependent. Well, then it's whatever. Debuggability and null terminated strings. That's a mistake, in my opinion. Python versus Go. I would say if you're writing small programs, Python still wins. If I have to write something quick, get something out, test something quickly, just fire up Python and do it. But when your code exceeds 1,000 lines, it starts to run out of steam. You start to miss the formality that Go has, where you can say, this is what I expect, and all that. All right, I'm going to skip through all this and give you one cool example. Oh, here is one. Actually, I'm going to skip this because a lot of people have talked about interfaces, and you all know how to use it. Here is a cool one. This actually we stole from Brad. He doesn't know that we stole it. So here is int64, and the sync/atomic is not very cool to use because you have to pass it addresses or values. Instead, what we did here was define those atomic functions on top of an int64. And so now this int64 is a type on which I can do atomic operations, just like it was a normal type. And it's pretty cool. Oh, closures. Closures are actually, in my opinion, underutilized in Go because people are scared because they are slightly syntactically weird, but they are very, very powerful. Closures basically are first-class citizens in Go. You can create them anywhere, use them anywhere, maps, slices, function arguments, and here is an example of a cool usage. So I have an implementation that has to do begin and execute. They are different functions. It has different, like you see, begin actually just returns an error, execute accepts a query and returns a result. But then both these functions have to be executed on a connection, but I want to add retry logic. I want to say, oh, if it's a failure, then I want to retry 3 times, and then after I retry 3 times, only then I have to return an error. So in this case, what I do is I have written a with retry function that's completely independent of these two. What it accepts is actually another function, and calls that function, looks at the return value, and then if the return value is fine, it returns it, otherwise it retries. And the problem typically is that if begin and execute had the same signature, you could have defined retry to have that. But in this case, they have different signatures. So the technique I use is that within begin, I say return with retry, and I create a function on the fly that satisfies the interface that with retry expects. And then it calls internally begin and returns the correct error. But then in execute, as you see, it does the same thing, except that it sets a local variable as the result and returns the result at the end. So you can do, I think you must be familiar with Python's closures, Python's decorators. So this is kind of similar to that. I thought it's a, so basically a closure is basically a single interface function. That's basically how you see it. And some of these cool things you can do with, here is another example of an anonymous closure where I begin a function, do a lock, and then in the middle I have to unlock maybe to wait or something. I can create a local function right within and do my wait operation within that. The reason why I do this because I can use defer inside a function. Switch on types are cool. There are many places where you can use this instead of enums. And Vitess has a bunch of reusable parts. You can reuse the BSON library. We can use bytes too. Basically, it's same as bytes, except that it's a chunk writer, which means that it doesn't keep on appending and reallocating memory. It just keeps allocates in chunks and then gives you still a bytes interface. LRU cache, I've seen a few people use it because it's kind of generic. CGZip, faster gzip, basically it wraps the C API. Memcache client, if you like to use it, it's a very simple one. I think Brad has written one which is sharded, right? Yeah. There's a MySQL API which is also bare bones. Connection pools, you can use that generic library if you would like to use that. We have the proc, which actually lets you restart a server without a downtime. It negotiates with the previous server, transfers the listener, and then you never miss a beat when you're serving traffic. RPC Plus I've talked about. There is a stats package that we have, which is built on top of EXPVAR that gives you more advanced stat values. Sync2 I've talked about. and timer is for housekeeping. You can go look at the repository. This is our dev team. We are 5 of us right now, and very excited. We have now some operational people also that know Vitess pretty well in Google. We are hiring. All right. Okay, we have 6 minutes of questions. Yes.
What are some typical queries that you blacklist? Like some types of queries that you said that you can usually blacklist or identify that with the parser you can?
So the question is, what types of query do you blacklist? How does the parser help with the blacklisting? So one example was there was so the parser actually, when it this was actually something that I initially used a blacklist for, then I eventually removed the blacklist to actually make it hard coded in the code. Was when the parser, when it creates an execution plan, it says this is the category of execution plan that I've done, and one of the plans was pass through DML, which means that the parser says this DML is complex, but I'm going to let it pass because we still haven't cleaned up the code base yet. So then we went and cleaned up the code base and don't have any of that category anymore. We didn't want to allow any more of those. Then I say go to the query blacklister and say anything that comes as a pass-through DML, don't allow, and then add the rule, and then it stops allowing it. But now we have said that we don't want to ever allow pass-through DML, so we went and hard-coded it in the code and removed the rule. That's one example. But you can blacklist by other things. If it's an insert statement, if it's a select star, you can do regular expressions and stuff. It's pretty powerful. Yes?
So this is not really goal related, more with the first part of your talk.
Yes.
And you mentioned it yourself that in YouTube you have lots of content which they get popular very quickly, and I guess this will fade out and they will belong to the long tail. And my question is, now that you have automated all this sharding and so forth in MySQL, have you done anything to actually make more popular content also more replicated? Do you do this automatically or not?
I didn't fully understand the purpose of your question. So you?
I can rephrase quickly.
Yeah, yeah.
Since you are automating sharding,
Yes.
and you have tools for that, are you also trying to adapt the replication of your MySQL databases to how popular the content is?
Oh, okay. So the question is, are you smart about how you shard the database to? No, we don't. Actually, we did an analysis that of our query traffic to see if there are any hot areas, and we didn't find that we didn't find any pockets that we felt like was worthy enough. So the only technique we used was our user IDs increased sequentially. So what we did was, that's not a good idea because then new users will end up in just one database all the time. So we hashed the user ID and then sharded equally using that. That has been good enough. We do know that it could happen. So if it does happen, our game plan is to shard very narrow if there is a hotspot. If, for example, a particular user or a set of users end up within the same zone, we could shard very narrowly there. The shards don't have to be uniform, so we can just narrow down that thing into a separate shard. But we haven't had to do this so far.
Did you not support for transactions at all, or you can still do transactions with Vitess?
The question is, are transactions still supported in Vitess? The answer is yes, in a limited fashion. We give you guarantee within a shard or within a key space. If it goes beyond key spaces, then the way we recommend you do it is sequence your DMLs in such a way that you can recover from it. We are actually writing tools that will do consistency checks. Those are coming. Yes?
Are you using the SQL database interface with the USB or something else to talk to the SQL database?
To talk to the SQL database, we wrote our own client library, and we have our own SQL parser, which actually supports which does not support intentionally all constructs of SQL because they are not all good. You don't want to do roll-ups and stuff with MySQL when you're serving web traffic, so those things we don't allow.
So that's why you're not using the interface from the OSCD, the driver of the OSCD?
Oh, the Go's standard library. Actually, there is a different reason why we don't use it. The reason is because we use bind variables, and they are not compatible with. I wasn't able to make it work with Go's standard library. I should talk to Brad about it sometime, how to make that work, because we have named bind variables. They are important for us because that uniquely identifies a query. Whereas Brad's library supports the question mark, the anonymous bind variables, which don't work as well. Yes. Yes.
You mentioned adding sample support in Office and Cloud.
Yes.
What sample would connect?
The question is what SASL mechanism we use. I didn't implement it. I believe it's CRAM MD5. If that answers your question. Yes. Okay. Yes.
Are you aware of anybody else trying to run Vitess? I mean, like.
Oh, we actually don't know. There was one person from Russia who they went very far. But they didn't tell us what they were using it for. They downloaded it. They kept asking us questions about how to make it work, and we answered all the questions. And once everything got working. Radio silence. So I don't know. I don't know what they're using it for, or if they are using it. So we don't know that yet.
Okay, thank you very much, Sugu.
Thank you.